Well, good morning, and thank you for joining me here in my shop. We're going to be working on first this tube tester, and I have a bunch of them. We're going to be going through over the next few videos one by one. I'm going to get familiar with them. That's my intention. So this particular tube tester has no cord to plug it in. I got this, I believe my good buddy SH gave me this quite a few years ago. I think he was cleaning out a little bit. So as far as I know, I've never plugged this in. I've never tried it. I've never used it. It's just been sitting around. I have two other tube testers that I like to use, which are of a better kind of technology, if you like, or test tubes in a better way. So this is a very simple kind of tube tester called an emissions tester. And let's just set all these to the neutral spot in the middle here. Let's see, just looking at the face of it, lots of different sockets, filament control, some kind of adjustment called a shunt, and line adjust. Oh yeah, this one snaps. Looks like an overload light, tube short light, line adjust. Here, wait a minute, what's this? Line adjust, line adjust. Wow. Okay, so you can hear there's a wire resistor in there. You can hear that. Oh, it's an awful lot just to adjust for line voltage here. Holy smokes. Looks to be in fairly good shape, otherwise let's try the roll chart. Yeah, that's not so good. Okay, well, I think the next thing to do is to take it apart and look inside. There isn't very much to one of these. Emissions tester. So likely what goes on when you set this up to test a tube is it ties all the non-cathode elements together as if they are all plates, and then places a DC voltage between all those elements, including the plate and the cathode. And that causes a current to flow. Given what the voltage is that you're applying to the plate, the current causes the meter to go up, and the people who designed this have set it up so that it's calibrated. So when the tube you're testing obviously falls into good, it's okay, and if it falls into replace, it's bad. And there is no precision to this at all. Precision? No precision? Quantitative. It's not quantitative. The other tube testers actually amplify a signal. Have a way of comparing the amplified signal to the input signal on the tube and deriving the tube's transconductance, as it's known. This guy can't do that at all. You just get current flowing through the tube, basically, and if the current is enough, the tube is good, and if the current is low, the tube is bad. Pretty simple. Probably enough to test a tube effectively 90% of the time. Because even on the dynamic tube tester, a tube could test good in a dynamic tube tester, the kind that actually make the tube amplify. Well, you put it into your item that you want to operate and it doesn't work. The tube won't work well. So there's no 100% guarantee with any of these tube testers. Again, with a lot of this stuff, it really has to do with what's going on in your head. Half of it is what's in your head. There it comes. What am I going to do with it? So there's the cord. Let's see. It's going to be a tricky guy to stand up. Well, it's a good thing they used basically two colors of wire here, and that's about it. Boy, it'd be tricky tracing all this stuff around if you wanted to, but it's really pretty simple because I have already studied the schematic. What I'm doing right now is I'm just looking for any burned out resistors that I might be able to spot in here. There's a big wattage one here, big wattage one here. Everything looks pretty good. Lots of resistors tucked up in here. A couple of light bulbs here. This must be a pin straightener. It's got no wires on it. Oh, it's nothing on the top either. It's a blank. Okay. How do you get in to try to fix the paper, which has probably come loose somehow off one of the two wheels? That doesn't look like the easiest thing, does it? You can already see that there's a screw protruding right here, and the paper is getting caught on it. So we'll have to take a closer look at that. One of the nuts just fell off. Not a lot holding it on. So what can we do with this guy? I don't believe there's anything to calibrate here, because the way they do this is they set the switches the way they want to set them, run the machine, the meter goes up, that's the reading. That becomes the reading in the factory when they're designing all this. So there's no calibration back here. There's a paper capacitor here going to this light. Take a look on the schematic for that. There's something right here on the tube. This is the rectifier tube, 6H6 rectifier tube. It's rectifying the high voltage coming out of the transformer here. There's many voltages coming out. Rectifies it, and then that's applied to the plate. Doesn't seem to filter it. I don't see a big capacitor filtering anything. And it may not. It may not filter it. Again, it's, you know, basically you build the machine, you plug the tube in, you turn it on, you set all the controls where the meter goes. If you put a new tube, that's where the meter should go when that tube is tested. I think that's almost the level that this is done at. So the question is, should we just put a plug on the end and let her rip? Just set it. I think I can set it like this. Take a look at the cord. Normally, the cord's not too good here. Normally, people cut the plug. Here's it's damaged here too. When they cut the plug off, in my world, that's and leave this cord on. That's a message that there's something wrong with this. Something wrong with the machine, not the cord. Okay, so for the sake of convenience, I'm just going to tape over these two bad spots here. Leave this wire on. It's nice and flexible, rubbery wire. This is supposed to be the easy way of doing this. Yeah, there's There's no way this is going to go in there. And you can't tell how far you put it in. It's got to go all the way to the bottom to receive the spikes. So waste. Okay, this is what happens when you try to do things the easy way. It ends up not being easy. Okay, let's tidy up on the schematic here. Since I have to replace the entire cord, I'm going to be replacing it with a polarized plug, and maybe there's an issue about which way to wire it. So here's the plug part up here. Let's see, that's a little unusual. What's that? So, this is how you vary the or compensate for the input. Well, this is the line adjust. This must be the wire wound line adjust control. We'll probably find the other line adjust in here somewhere. Just looking for it now. I don't see it. We got this thing. We got this thing. Oh well, not to worry about it. So the issue here, you're going to replace the plug. Is this one of these wires somehow connected to the metal chassis or frame or box of the device? So as I look at it here, it sure doesn't look that way. It would look like there's no connection anywhere in here, no capacitor or anything going out to the chassis. So I'm going to use my eyes to verify the same thing, but it would look like you could plug this in the wall and there's no wall power anywhere in here in any way as such. Filament switch, B1, B2. Grid caps down here. There's the meter movement. There's the rectifier tube. It's got the guy's name on it right here. Looks like Fisher, Mr. Fisher. Lever action. Look at these levers just for a moment here. The way these work is really simple. The center one is I call it a ground return, if you like. Look, it just goes up, ties to here. So if you take switch 1, you flip it down. It's showing this very poorly pictorially, and you can't even imagine it going down, but flip it down to here, and this will be where the pretty sure, yeah, that's just a light test thing. This is where it picks up the filament voltage. Yeah, right here. Sure, right through. So between here and here is the filament voltage. So you flip two of these, maybe one switch down to pick up to pick up the heater. By the way, these switch numbers all go with pins. So this is pin 1 everywhere. If you follow this, let's see if I'm telling the truth. If you follow this, oh my gosh, you get to here. That says pin 1 right there, believe me, that's 1. So this is pin 1, pin 2, pin 3. So it's very simple to operate this. So this is the beauty of this machine, it's real simple. So you'd flip down, let's say the heater is pin 3 and 4, so you'd leave 4 on the center like it is now, and flip 3 down to here. Now you'd have the heater engaged. All the rest of the switches are flipped up or left, just left here. The ones you flip up are going to pick up the high voltage coming out of all this, out of here, rectified, and messed around with. I don't know if that's very clear what I said, but it's clear enough for me to carry on. So putting the cord on here seems to be no concern with this, according to the diagram. But let's look at the actual machine now and see what's really going on there. So one wire is coming to this location here, Really? This is not how this looked. This must be the fuse light. I didn't see that in the schematic. Circuit overload light. So basically all the power going, this is a dim bulb system. That's really what this is. This is the dim bulb, and if you have a short circuit, a lot of power is going to be drawn into the machine through the bulb's going to light. Then this must provide some calibration or compensation for the particular resistance of the bulb not being absolutely appropriate for this use. Something like that's going on. Very loose socket. And then it goes right into the winding here. This is just shoved in here. It would be really, well, it's got a rubber grommet. So I think they're relying on the rubber grommet to ensure that this doesn't touch the chassis here, the deck plate. Okay, now the other wire, the other side of this has to get over to here. So let's trace back from here. The wire comes right in. Here's the power switch. Okay, I'll show you what can happen here. This is how people get electrocuted. This could be why this cord is. How much you want to bet? I'm going to show you why this cord is cut off. My buddy SH may have got a lift off this and said that's it for that. I'm just looking for my close-up camera. It's right there, for crying out loud. Now I don't know for sure this is a problem. I'm going to take a closer look at it and maybe even do a little test on it. Okay, so you're looking down, right down at the switch. Right down at the switch. How do people get electrocuted in shops like mine? So we have the power wire coming in right from the outlet, comes around, ties to this terminal. You see the angle the switch is on? The switch is rotated, and this terminal, I need more light to make this show up on the camera here. This terminal is in contact with this, and if it's not, it is really, really, really close. Let's see if we can stick a piece of paper down there. I'll use my meter to check this. That's stupid. That didn't work. Let's see if that really is a short there. It may look like a short, but it may not be. Okay, from the power line, I don't want to disturb it, so let me just touch it. Here, just touch it. Huh. Okay, I'll clip it on there. I guess it's saying it's not shorted. How close is it? So I'll just try moving this a little bit and see if we get a. It's just a billionth of an inch off. The clip lead's going to short it out. I may have bent it with the clip lead. Let's go on the other side of the switch and turn the unit on. Still seeing no short. So maybe there is no short there. What happens if I just finish it off here with a screwdriver? Yeah, that's right, Peanut. I was right. So it is really, really close there, but not a short. Okay, so the switch is rotating now. It's loose. So if that wasn't a short, boy, it was on its way. Definitely on its way. So that, that's basically bad engineering. you think the design guys would see that and go, wait a minute, you have to solder right in there close? It must have been obvious to everybody. I'll bet you they had an administrative control on that. Special instruction. Careful when you solder that. What you thought about the switch coming loose and rotating? I'll bet you this is an accident that happened again and again and again in these machines. And now whether my Pletty SH got a lift off this or not, maybe not. We don't know. But I don't want, so this is exactly how you get hurt. Now this is a lousy repair here too that I'm doing because this tape doesn't last forever. But at least while I'm working on it here, I'll have it better protected. Okay. I guess it's worthwhile to inspect the AC circuit really carefully in something like this before plugging it in. Something like this being anything like this. So off of the switch, it then goes into this rheostat. The rheostat has two wires coming out of it. Back over to the transformer here. So again, I'm looking for connections to the chassis. So I think that's it. I think that's the end of the circuit, really. I have to get back to probably a black wire. There's probably two black wires make the primary. Maybe not. You only see one. These wires are stiff, so they can't be moving them around too much. Yeah, I only see one. So I don't know the color coding of the transformer. So what does come over here are these two. These two. These are going in the other end of the transformer. Well, I can't imagine this is wired wrong. Looks like nobody's done anything to it ever. So it should be able to plug this in, turn it on, and first of all, no electrical hazard based on a chassis here, although I'll test for it. But before doing that, why don't we just take a look and figure out where this capacitor actually is. Something to do with this light here. .005. I don't remember seeing a capacitor on the schematic. Having to do with the light. There's a capacitor, C1. C1, have you listed over here? C1, 0.01. What? Wait a minute, that's the only C. Is that right? One capacitor. 0.01, but it's 0.005 in my machine. Here we go. What is it doing? Short merit. Oh my gosh. Well, the rectified output of this output's here. I don't know what's going on here. I have to study this for quite a while to really sort it out. But that looks like the only capacitor in here. Now where's the meter movement getting its juice from? It's getting it from over here somehow, over here. I don't know. I have to sit and, doing this live on a video and trying to sort this out bit by bit. I think it's too brain teasing for anybody to watch. It's too brain teasing to do it. So we'll skip that deal, and so So what if this capacitor is shorted? Well, obviously it's trying to stop some DC here. I mean, why else would it be here? Why else would it be here? There's no signal in here. There's no alternating current signal in here at all. So it must be blocking DC. Maybe something to do with the heater circuit in here. I don't know. Keeping DC off the heater circuit. I don't know. C1. 0.01, 0.005, maybe it doesn't make much difference. Should I replace it or not? We can test it. So if I test it, it's open here. So it's open, it's not open through here. Yeah, I don't know if I can test it in circuit or not. This way, hey, you know what? If I flip this, if I push this to merit, it'll open this switch, and this is going nowhere. So yes, I can test C1 with my capacitor checker. Hey, let's give it a go. Okay, I am looking for excuses to use my tuned up equipment here. Okay, let's try it now. It's a little hard to see the gap in the camera, but I think you can see it there. Okay, so first we'll test it first with the me not pushing the button. Well, you can see it. Can you see it open? Yes, you can. Flies right open. 150. Doesn't fly open at 150. Now I'll push this button. That should remove it from any circuit. Same thing. So hard to see in the camera there, but the eye is only opening not quite halfway. So that's a bit of a leaky capacitor. Doesn't matter there. I don't know. It's a tube tester. It's trying to control a very, very small current going into the indicating meter. If you throw that off a little bit, I think that might make a big difference. So maybe the answer is yes, a leak here might cause a problem. Now what's this other one? It's connected to one end of this capacitor near the rectifier. Let's go take a look, see if we can figure that one out. So right up near the rectifier, well, it's located physically near the rectifier. It's connected directly to the end of this other capacitor. So this wire comes up. This must be it here. So it appears to be connected across terminals, but it could well be one of those terminals is unused. So it's a tiny what? Resistor. R6. A 1% resistor. That's why it looks funny. 95,000 ohms. Okay, so we'll try measuring that. Should be able to measure it. This end's open. 95,000 ohms. Let's check it out first. Make sure it goes to 0. Yep. $96,000 ohms. So is that within 1%? I thought 90. Let's see, 1% of 95 is 1. 96. Yeah, I guess that's within 1%. It's probably the value it's been all along. Again, this is not a quantitative testing machine, so absolute precision just can't be important anywhere in it, I would think. Okay, so this guy's got to be changed out. I'll put in a 0.01 or 0.05. 0.005. Whatever one I've got a lot of, someone I'll put in. Okay, I'm just going to nip out the old one here. Bottom of this resistor where the green wire connects. that's going to focus on its own. Jeepers. Bit of bad lighting here on the camera. "85 TOC." I'm not sure what that means. Again, no precision in here, so I shouldn't be too panicked about anything. So all these resistors over here look pretty good, and until operating the machine, until I get some notion that it's not working right, I think I would leave it as is. Here's the cord I'm going to put on it. There's no issue around the polarization. The cord has to go through the box. Right. Okay, so put this through this way right away. Okay, let's do the power cord thing. Now, they've got a knot here, so it won't tug out the back. I'll try to imitate that. It's not a particularly highly engineered arrangement, is it? Good. arrangement there. Now I'm the guy making the connection into here. Okay, let's pull this wire out of it. Huh. I just pulled on it. It just came right out of there. You're going to tell me this whole time this wire was never soldered onto that terminal? Are you going to tell me that? I'm going to tell you that. There's no solder on the end of the wire. Wow. I wonder what kind of problems this thing had. Let's just melt that off there. What is that? Okay, let's see if I can get my wire in there. I want to tin it up first. This wire doesn't want to tin. It's way too big to push through a hole there. Good spot here to make a connection. I wonder if I should take the you know what I should do? I should take the switch right out. It's loose already. Really the wrong way to. Yeah, there we go. So interesting. Something under there. did they put under that nut? Looks like a little bit of glue. Somebody try gluing this? Out. Maybe it'll do a much better job now. First we want to get the solder out of that. Oops, down here. Get the solder out of that. Go. Now we got a hole to stick the wire through. It's a really thick wire. Never going to go through there. Okay, we're going to shrink down the wire a bit here. Perfect. That's pretty good. There's no exposed wire. Don't even need this. The idea was to get it to go right over the top like that though. Bring it around. Now, why these two things? What about a lock washer? Do I have a large enough lock washer to go on that? Let me check. Make sure it's straight, which it is. It's a much better tool for doing this with. It'll fit. Yeah. We can see the lock washer's gone flat already. There we go. Good. Turn it off. So, what would be the reason for us not to turn this on at this point? No reason I can think of. Any problems in it? Probably not going to cause any kind of disaster. Flip it back into the cabinet. Oh, the paper. Just putting it in the cabinet temporarily anyway. We'll worry about the paper roll later. Drop out. Put in just a couple screws here to keep it from falling apart on me. Great. Okay, so we're just about ready now. We are ready now. Start them up here. Off. Line adjust, line adjust. There must be a button you push for line adjust to enable it. That's a mystery. Well, that's a mystery. Right away. Okay. Let's carry on. Let us not be afraid by mystery. Mystery is where the fun is. So I'm going to flip this on with the dim lights. This is off, so we should see nothing. We see nothing. Now we want to check this for a couple quick dumb safety checks here. No light. Turn this guy on. We're going to switch them on. What I'm going to do, I'm going to turn off the power, turn on the switch. I'm going to put the power on from up here. Watch those lights. These two lights came on under here. Nothing else happened. So right now the little rectifier tube would be heating up. Now, how do I get the line adjust to happen? There's only one button on this thing. Must be some trick to it. Well, let's see. I have a tube here. I have a 12 AU7. We can't roll the roll chart. Yes, we can. 12 AU. Getting there. 12 AU7. There it is. Let's give it a go. Let's give it a go. Shunt 25. Filament 6.3. Okay. Selector 2. Oh, so this is the selector. Couldn't they have needed something a little less generic than that? The up are 6 and 7. Incidentally, this tester, you dare not plug a tube into it until you have the whole thing set up. This is a, and then the down position is 4, 5, and 8. 4, 5, and 8. Now, as we know, one of these is energizing the filament, probably number 4. These other two are being put in a ground position to ground them out of the picture, I believe. That's what's going on. And this is probably, let's see, this is a tube. There's 2 tests for this tube. Let me get it right now. Did I do this right? So I'm doing the second test, actually. 6, 7, I don't want to get it mixed up. 4, 5, and 8. So I'm doing the second test on a 12 AU7. And notice this is set to 6, not 12. Yeah, that's another place where you could easily blow up your tube. Okay, here we go. First time ever sticking a tube into this. Still don't know how to check the line adjust, because I haven't bothered reading the manual. Well, it's warmed up. Is it just supposed to go up and read? There's no test button. There's only this. Merit. So, merit. Okay, so I had in my head that this button was an attempt to run this thing in what's called life test mode, where you basically drop the heater voltage a little bit and see how the tube behaves. Gives you a hint as to how strong the tube really is, or how much capacity it has for life capacity. I don't know, let's push it. There we are. Good. So, I mean, it's the only button I can push on this. So merit must not mean that. Merit must just mean test it. It's good. Tester seems to be working. I have another identical tube. 12 AU7. I'm not sure I have a bad tube handy. Maybe I do. I'm afraid I dumped my garbage on garbage day, so the bad tube went out with it. I had a gassy tube. Right on this guy. Very same reading. So I guess you could do comparative tests for sure. And it would probably be pretty good at telling you which tube is the better one to use. Now, I have some more tubes laying around here. Let's grab one. Let's grab a few. So I think this is a 6BA6. 6. The roll chart does seem to work. These roll charts are always kind of clumsy. Anyway, maybe it was just at its limit. 6BA6. Here we are. Tube is out. Return these all to neutral. That's probably the best practice with this one. So 23 on the shunt. Okay. 6.3 again on the filament. 3 on the selector. I don't know what I'm selecting. Oh, that's a line adjust. Huh? What's going on here? That says, I got it. Okay, I got it. I figured it out. Let's do this now. Line adjust. I turn this all the way over here. Now we're on line adjust. Okay. See, I didn't even have to read the manual. Turn it up a little bit. Good. This kind of tester, you should probably do the line adjust while the tube's in place. So we'll try it again. But otherwise, for the sake of the test, this adjustment should be on 2. And then the up is 1, 2, 5, and 6. 1, 2, 5, and 6. And the down is 3 and 7. 3 and 7. 6BA6, 23, 2, 1, 2, 5, 6. 1, 2, 5, 6. And 3 and 7. Okay. We're set to test the 6BA6. 6BA6. Different socket this time. do the line adjust now. Just a hair low. It was 2, wasn't it? This is where I can make a mistake. 2. Is this a good tube? Good, really good. So I think this tube tester will give you good feelings. I think it'll do that. What else do I need to do to it? I don't think I need to do anything to it. It's a little bit disappointing in a sense. Thought I'd be doing lots of stuff. 6BA6, so we can rip through a bunch of 6BA6s here. My old military radios love these 6BA6 tubes, so I've got quite a few of them that I've been saving over the years. Test. Another good one. Well, my wife just came down and told me that our daughter-in-law is in labor. So I'm going to be a grandfather in just a few hours from now. Hey, isn't that something? Yes, it is something. Okay, how are you? Right up into the good. So eventually I'm going to be going through, I've got another 1, 2, 3, 4 tube testers to look at. I bet you if I look around hard I'll find a 5th one too. So just as I did with the voltmeters here, I'm going to go through these one at a time. I'm starting with the simplest one. I'm going to build myself up to the more complex one, although none of these are terribly complex, excuse me. We'll just work our way through them one at a time. And in the end, I'll have a number of tube testers, and I'll be able to take the same tube and run it through the various tube testers and compare them, how they respond to a given tube. So, good shape. I think that's it for now. I don't think there's anything more I need to do. Fantastic. And I'm going to go off and practice being a grandparent now. See ya.